In the last video, we showed how to discover Pascal's triangle to maybe help us do a plus b to the fifth. So we're going to expand a plus b to the fifth. So we have to look at patterns. Just look at the a plus b to the third. We have a to the third, then it drops down to a squared b, then the power on a goes down to 1. While that's happening, the powers on b are going up from 1 to 2 to 3. So it looks like if I just look at the a powers and b powers, we should have a to the biggest power, which is a to the fifth, then a to the fourth, drop it, a to the third, a squared, a, and then the a disappears. While that's happening, the b's are increasing from 1 to 2 to 3 to 4 to 5. Notice that the two powers in each of these terms always add up to 5. We have 4 and then the 1 on b, the 3 and the 2 and the 3, the 1 and the 4, and then b by itself. The coefficients are going to be found in this row of Pascal's triangle. We showed you how to get each of the terms of a row. So then that would make it a 1, a 5 here, a 10, a 10, a 5, and a 1. So we now have expanded a plus b to the fifth. Well, what if it was 2x plus 3y to the fifth or to the third? Well, the same type of thing is going to happen, but this is going to be your a now. So what I'm doing here in this problem is I'm representing the a as a triangle. So up here we have a cubed, a squared, and a cubed, a squared, and a, and the b's would be the squares, the b to the first, b squared, b cubed. Then you can just plug in the 2x where you see each of the triangles, and you could put a 3y in the place of each of the squares, getting us this answer right here, which really needs a lot of expanding. So we're going to have to multiply out all the terms to get our final answer. We could even do something with a negative sign in here. We could also do like 4x minus 5k to the fourth power. But now be careful, you're going to want to make this a plus and put the negative with the 5k to go into each of the squares.